9.4 today. Are you ready? If you need to sharpen your pencil, you better do that right this second. Probably not there, Matt. Oh, goodness. I hope you guys have your activities ready from the boxes from 9.4. That was the only other thing that I asked you to do.
I heard a couple.
Ben, you don't even have your books open, ready to go. What's going on? I thought you were going to be the star of my show.
I'm definitely
We're going to go through the activities kind of quickly because you should have already had them done and ready to go. Okay, here's your problem of the day. Ready to go. Little review from 9.3. You may already have this in your notes. So you might have to look back, try it from memory, or look in your notes. Want to know about the inscribed angle theorem, the right angle corollary, and the arc-intercept corollary? Page 582, if anybody's wondering. Okay. Help me out with the inscribed angle theorem. Tell me what it is. In your own words. How would you describe that one? Anybody? Susie?
If an angle is described in a circle, then the intersection arc of the circle, but the angles measured is equal to half of the length of the arc.
Okay, it ends up coming out to be half of the motive measure of that arc that it intercepts, right? How about right angle corollary? Matt?
If an inscribed angle intercepts a semicircle, then the angle is a right angle.
Okay, if it intercepts a semicircle, then the angle turns out to be
Right
a right angle. Okay? And arc intercept corollary, Margaret.
When you have two inscribed angles and they intercept the same arc, they have the same angle.
Okay, good. When they intercept the same arc, then they have the same measure. Good. Okay. You can open to 9.4, page 588. First thing we're going to look at is what kind of angles that we're going to be talking about today. They're angles formed by secants and tangents. Here's all different cases. It all depends on where the vertex is and the type of lines that it includes. If the vertex is actually on the circle, you have secant and tangent right here, or two secants here. The second group is where the vertex is inside the circle, but it's not on the center usually. Okay, talking about here. Last group, vertex is outside the circle. You have two tangents, two secants over here, or a secant and a tangent. Okay, that's all going to help you determine how to find the measure. All right, you ready to go over the activities? Take that out, whatever you brought from Friday for homework. We're not going to go over each one of these in deep detail because you should have already had most of them done. We'll go over the first probably row or two, and then we're going to talk about the general pattern at the end with X. So, first one. If you have this circle with secant and tangent, the secant-tangent angle is a right angle here. Okay? The secant contains the center of the circle. What do you think the measure of ABC, angle ABC is? What'd you come up with, Michaela?
90 degrees.
Why do you say 90 degrees?
Because it says that the secant tangent angle is a right angle, and ABC is the secant tangent angle.
Okay. So, and the measure of a semicircle here, arc AV, is what? 180 degrees. So what can you get from that? If the whole arc is 180 and the angle's 90, what does that kind of remind you of?
It's half.
What's that?
The right angle.
Okay. Yes. Kind of like the right angle one, or where basically because it's half, right? It's 180 degrees and this is 90. You can come up with this checkpoint here that says the relationship between the inscribed angle and the intercepted arc is the fact that it's half of what that arc is. That was the easy part. Okay, look at number 2, the secant-tangent angle. We're going to go over, this was if it's the tangent and it's a right angle. Next we're talking about the acute angles. What happens if the angle is acute? It's not a straight, it's not coming straight from through the center. So that's going to be a little bit more tricky for you. Look at arc AV. It tells you it's 120 degrees. And then it gives you 120 degrees for angle 1 here. How do you know that? How do they justify that, Leah?
Because the central angle and the central angle, the arc that they intercept equals the measure.
Good. That's back from the beginning of the chapter where the central angle is going to be the same as whatever that arc that it intercepts, correct? Angle 2, 30 degrees. Where do they come up with that one? Go ahead.
Triangle APV is isosceles, so angle 3 and angle 2 have to be congruent.
Okay.
And since all angles in a triangle have to add up to 180 degrees, you take 180, you subtract 120, and you divide the remaining 60 by 2.
Very good. You get 30 degrees. So where do we come up with this one? PVC. PVC. That's the one they left blank in this first box. You're on a roll. Let's go.
Yeah, PVC has to be at right angle because it intersects the semicircle.
Okay. They say radius to that tangent. We learned that
Oh, yeah.
back in the beginning. 9.2 or 9.3. Had to be 9.2. We just went over 9.3. 9.2, that the radius that intercept that has that same tangent point, that's going to be 90 degrees. So that wasn't the hard part. Measure of angle AVC. How would you get that one? AVC. They say 60 degrees. Go ahead.
If PVC is 90 degrees and angle 2 is 30 degrees, then you do 90 minus 30.
Okay, and you get 60. This kind of, this being 60 degrees, how does that relate to back here, the arc? Matt says it's half, Mike says it's half. Okay, so the measure of an acute secant tangent angle with its vertex on the circle is 1/2 the measure of the intercepted arc. So we got two cases down. We got, if it's a 90-degree angle with the secant and tangent, we got acute angles. What do you think this general statement here? Measure of arc AV. If it's X, what's angle 1 going to be? X. Okay. What about the measure of angle 2? Michaela, describe that for us. Susie?
You first have to do 180 minus x, so triangles up here, and then you divide it by 2.
Divided by 2.
Yeah, the angle back to
These angles are going to be the same. Okay. How about PVC? That's going to be 90 degrees. Okay, that's not gonna change. And so the last here, this angle, is going to be what?
Half of the arc.
Which is
FX.
X. Okay. So we know it works for that same intercepted arc theorem. Works for 90 degrees, works for acute angles. Last case is obtuse angles. This one was a little bit more tricky. You might have had a little bit more trouble doing this one. If it's obtuse, they give you AXV around this way is 200 degrees, and they come up with this measure of angle 1 being 160. How do you think they got that? Melissa?
A whole circle is 360 degrees, so you have 360 minus 200.
Good. If you have that whole circle is 360, then the central angle on the other side, if we take away the 200, it's going to leave you with 160. Okay? So that gives you angle 1. Measure of angle 2 here. How do you get that one?
The triangle.
Triangle,
Serum. The theorem. It has to be equal 180.
okay, equal 180. So,
If angle 1 is already 160, then angle 2 and angle 3 are equal.
good. That leaves you with 20, which means one of them has to be 10. Okay, how about PVC? Anything different about that one than the other example? No, it's got to be 90. I'm just going to copy that one down right now. And how about the last one? This whole AVC, the actual obtuse angle, says it's 100. If you're following a pattern, what are you getting?
Half.
It's going to be
Half.
half. Okay? So I'm just going to fill this in now. Measure of an obtuse secant tangent angle with its vertex on a circle is 1/2 the measure of its intercepted arc. So let's fill this in. For measure of angle AVC, how would you relate that back to x for any measure? X over 2. Okay, I'm just going to work my way backwards. We know the 90. Well, let's go to angle 1. How would you figure out angle 1? If you know x for AXV. 360 minus x. Oh, I was going to write x over 2. 360 minus x. And Katie, how would you do that last one, the angle 2?
Angle 2 would be the rest. I'll explain.
So it's a little bit tricky.
The 180 thing where it's like, I know how to explain it. I'm not sure exactly what the equation is, but I could do it.
Okay.
Like I can't do it.
So tell me what to do, and we'll try to put it in X for you.
All right, you have to get the measure of angle
Wha-
APV,
Okay.
and then
That's 360 minus X.
yeah,
Okay.
and then you would take the other two since it's a nice isosceles triangle, and those would both have to be equal. So you have to divide whatever the original angle is. Like I don't know. I'm sorry. You subtract APV from 180 and then divide it by 2. That's what I
Okay.
do anyway.
So 180 minus what we get from angle 1. I'm going to put measure of angle 1 right here. Minus measure of angle 1, and then you take that and you divide it by 2. Good. Sorry. I couldn't fit all that in that little box. So you get the theorem. This kind of, all these build upon each other. You get the 90, the acute, and the obtuse angles. They all come out to this theorem where no matter what, if you have that secant and the tangent, could be a chord and a tangent, you're going to come up with what? If you have an angle that intersects with a secant and a tangent on the circle. It's always going to come up to be half of that arc. Any questions on that? I'm going to wait to give you an example for that one until we get to the other side. Turn the page. I guess I don't have one for this page, so we're just going to have to do this just out loud together. So look at the top for activity 2. They're kind of similar, but you have now where the vertex is inside the circle. You have the intersection of two secants inside the circle, and they want to figure out how you can get those angle measures. So look at the first one across for table 2. You have the measure of arc AC. Gives you 160. Then you have BD. That gives you 40 degrees. How about, where did they get measure of angle 1, do you think? It says 80 degrees. Where do you think they got that? Leah?
Arc AC equals 160, and angle 1 is an inscribed angle, so it's half of AC.
Yes.
And
Good.
since AC is 160,
Good.
it's 80.
Good. That's what we actually just talked about, reviewing from 9.3. So how about angle 2? Melissa?
Our B day is 40, and angle 2 is an intercepted angle of that, so it's half.
Okay. Good. How about ABC? It's 100 degrees. Similar to what we've been doing, but it's got a slightly different twist on it. Where do you think they could have gotten the 100 degrees if you're looking at that circle? ABC is the angle we're looking at. We know arc AC and we know arc BD. Where could they have gotten that 100 degrees? Okay.
There's 2 ways you can get it. The first way is to add the measures of angle 1 and angle 2 together. And the second way is to add the measures of the 2 arcs together and divide it by 2.
Okay, so Michaela says there's 2 ways she thinks. You can do 160 plus 40 and you get 200 divided in half, and that gives you 100. Or she got 80 plus 20 equals 100. Okay? Do we have anything to back up either one of those more than the other? Or do you want to just do the next row and see what we come up with? Let's do the next row. So the next one says if AC is 180 degrees, BD is 70 degrees. What about angle 1? Or angle 2? Those are the inscribed angles. If AC is 180, what does that angle 1 have to be? 90 degrees, okay, half. How about BD? 70 degrees. 70 degrees, what do you think? Inscribed angle?
35.
35. So what does that leave us with for ABC? With Michaela's first method, it would be, what did we come up with? 90 and 35 added together. What would that give us?
125.
125. What about the other way? If we do 180 plus 70, what does that give us?
250.
250. Divide that in half, you get 125. They both work. That's interesting. What do you think?
Is have the AC.
Okay, what Matt says.
That for measure of angle 1 has to be half of the arc AC.
Okay, so you're feeling, if we're talking about the general one, again, he says, we're down to the last row with X. Measure of angle 1 has to be half of AC. We agree with that? That's inscribed angle. How about measure of angle 2 has to be half of BD, X2. So what do you think about measure of AVC? Katie?
What if you added the two angles together at the top, and that was whatever that is, and since it's a triangle, you get the other measure, and then it's a 80-degree thing. See, you subtract that from 180. Like,
Okay, say that again.
all right, that you add the two angles at the top and subtract that one from 180 because it makes a triangle.
Okay.
And then it's on a 180-degree line because that's what a line is. So you subtract that from 180, and that gives you what the other angle is.
Okay. You're talking about AVC or DVB?
ABC.
The first one.
Yeah, that works for the other one too.
Okay. Is that a lot to do for a general rule?
Yeah, but it works.
It works. Okay. So now we have maybe 3 different ways to find it.
But that actually proves that what Michaela said works. 'Cause
Which
for the
one?
first
If she
that
did
we've
2.
got, both of them.
Well, both
Proves
of
that both of them work.
Both of them are like the same
got the
thing,
same
anyway.
answer as the other one that Katie just said, and that really
The
proves it.
125 and the 100 that we already went
Yeah.
over. Okay.
Because basically just adding angle 1 and angle 2 together is simplifying adding AC and BD together and dividing by 0.
Because if you do 180,
Okay.
if you do 180 minus 125, you get 55. Well, then if you do 180 minus 55, you get 125 again. So,
Okay.
Proves it.
Okay. Well, so let's look at the theorem that I want us to fill in. The measures of an angle formed by 2 secants or chords that intersect the interior of the circle is what? Blank. The blank of the measures. Which one of those methods would fit into that? We had 3 different ways. Which one would fit into there?
Half the sum of the measures of the 2 arcs.
Okay, so if you take the sum of the 2 arcs and you divide them in half, I think that's the one that fits best in there. Any of your methods were pretty good. Okay, Michaela had the 2 that I was thinking of, and then Katie had a third one that was really good. The measures end up being half of whatever those 2 sums are. Because not all the examples are going to be as specific as these are to follow through with with the third way to do it. Do you understand what I mean? You could probably do it yourself on every example, but that might be time consuming. All right, let's look at the very last one. You guys are doing really good with these patterns. BD, measure of arc BD is 200 degrees. Now we have the vertex of two secants outside the circle. Okay? We had it on the circle, we had it inside the circle, now we're dealing with the outside of the circle. A lot of you guys had this question last week when you were talking about that test. You have measure of arc BD, that's at 200 degrees. And then you have AC, the smaller one right before they intersect, 40 degrees. Then you have the measure of angle 1. They give you 100. Where did they get that? Measure of angle 1. I'm kind of following right along. Melissa.
It's the intercepted arc of, for angle of BD.
Good. Intercepted. Good. So it has to be half. Good. 2. Measure of angle 2. They say 20 degrees. What do you think? Go ahead.
Same reason as for measure of angle.
Good. You guys are following right along. Same reason, okay? The other one's 40, so this one's half. It's got to be 20. And then they get AVC. Back to this measure angle AVC. If it's outside the circle, what do you think? How do you think they got that 80 degrees? Ben?
You can do first. You gotta do 180 minus 1. And that gets you the measure of BCB. And then you do that plus angle 2. And then you subtract that from 180. And then you have ABC.
Okay, so you were going with that whole large triangle
Yeah.
sum. So he said BCB, if you do that minus angle 1, which was 100, that leaves you with what? That leaves you with 80, okay? You have 80, you have measure of angle 2, which is 20, so that gives you 100. So that angle V, ABC, has to be 80. That works, right? That works.
Or you could do, since AC is it's outside, the angle is outside the circle.
Which
And
would AC what? The arc?
ABC.
ABC, angle
is
ABC.
outside it, but it intercepts AC of the arc AC.
Okay.
The arc's 40 degrees, and since angle ABC is 80, maybe it's 40 times 2. It's that angle times
Maybe
2.
it's 40 times 2. Do you have something to back that up?
But it also
No.
intercepts arc BD.
Okay.
But if you do BD, which equals 200,
Mm-hmm.
plus AC, which equals 40, that's 240.
Mm-hmm.
Or no wait, do 200 minus 40, you get 160.
Okay.
Divide that by 2, and that equals 80.
Okay, because we're trying to stick with this general pattern of it ending up being, what's it end up being every time? We've been following this pattern of the angle turns out to be half. You're scaring me. Ends up being half of whatever pattern you're following, okay? The last one, we added the two arcs together because it was inside the circle. Now we have a different case. It's still going to be half, but Leah says it might be half of subtracting them because now you're outside the circle. Okay, so if you have your, what side is it on this way? If you have your BD and then your AC arc here, the angle's way over here. Subtracting them might make sense. Okay? Do you see what I mean? Subtracting them might make a little bit more sense.
AC's in the way.
Okay. And now Ben's idea still worked, but it might be difficult for you. You're trying to get something quick and easy. That's you're following this pattern. The triangle sum works, right? But that might take you a little bit extra work every time. If you only given the measure of two arcs that it intercepts, it's going to be probably a lot easier just to subtract them. Boom, get your answer. So, go for it, Raul. Read that theorem for me and fill in the blanks.
Measures of an angle formed by two secants that intersect the exterior of a circle is half the sum of the measures of the intercepted arcs.
Half of the sum,
Different.
half of the, what's it called? The difference. We're subtracting them this time. You did say that. I was trying to see if Raul would get that.
I thought that angle 1 was 100 degrees, right?
Okay.
And then in order to find ABC, you had, oh yes.
That was Ben's way of the triangle sum. We were trying to get down to that same general pattern of it being half. Okay? So if you subtract them, if you get the difference, that's going to be a quicker way to do it. Because you might not always have that triangle working for you there. That's a little, like you're doing it, but you're taking an extra step. Do you see what I mean? You're going an extra step. Basically, they just want to get the general pattern. It's going to be a lot easier for you if you subtract them. And then do it by half. Divide it in half. All right, I have an example for you. This is what we just did with a little twist on it. This is my example with a little twist on it. Given the measure of angle ABC is 60 degrees, measure of arc AC is 130 degrees, you have to find the measure of arc BD. I like how you wrote that like that. How'd you get your answer, man? What did you do?
I have the answer somewhere.
How though? How did you use it?
I did something.
You did something?
Alright.
Okay, see now I like how you're filling in those blanks. Write it out, show me what you did. May I write that up there for me? Take your book with you if you need it. Good, Katie. Some people had to draw a picture. That's good. Draw your own picture. Some people like to draw it, write an equation. Either way you do it, you've got to show me what you did.
The same for me to solve it.
Yep, I want you to solve it. Leah did hers with an equation. She followed with the subtraction. 130 minus x divided by 2 should give you 60 degrees, she says. She moved the 2 over and got 120. 130 minus x equals 120. So she filled in her blank with the x. X has to be 10 degrees. 130 minus 10 degrees is 120 degrees. Good. Anybody else want to tell a different way that you did it? Nobody? You? No? No? You all did it the exact same way Leah did it.
Yup.
That is absolutely amazing. That is absolutely amazing. Nobody can, okay. I'll let it go. Okay, that one was the nice one. That one was the nice one.
I like nice ones.
Not me.
That's not showing my work.
No, you gotta show the work. You have to actually do it. Okay, that was good. Good start on that one. What are you going to do first? Which one are you going to work on first? The RSU?
Yes.
RSU looks like the vertex is on circle.
Yes.
What can you do for that?
That's it.
Sometimes it helps if you draw a picture. Helps me to draw a picture. Oh, what are you doing over here? Which angle are you doing first?
Well, I haven't even found the problem, but I'm doing UT before I see anything else. This is simple for me.
Okay. Why do you think that one's easier? Why is that?
Because then, say like, question would be RSU. Question RSU. Well, that would be half of that.
Oh, I see. You're finding this arc
Yeah, this
first.
arc first.
Ah, okay. I like that. Not bad. How'd you get this on, Melissa?
It intercepts arc RU, so it has to be half.
Has to be half. It's the inscribed angle. Okay. Looks like just about everybody got the first one, RSU. Anybody want to tell me what you did? Katie, did you get that one, RSU? What did you do?
Since the point's on the circle, I just divided the arc by 2. All points are on the circle.
Okay, because the RSU, the point is on the circle.
Yeah,
So it has to be,
half of the arc.
okay, has to be half of that intercepted arc. Good. Where are you, Margaret? RVU. Where'd you come up from? RVU. Well, think about what we just did in the last example. When it's outside the circle, you know RU, that was given, and you know RS. Oh, not RS, ST. So you have 140 and you have 30 degrees. Okay, you started to subtract. You changing your mind? No? Okay. So what are you going to do with that? You got 110.
No.
No, yes, no. Maybe? Yes? Look back here. What did we just come up with for this one? Think about it. I'll be back to you. USB. USB. How did you get that one?
Because RSU is half of 140, so 70, and that's a line, so it equals 180. 180 minus 70 equals 110.
Okay. Did you follow? Explain that to me again. Tell me what you just said again.
This angle, RSU, equals 70.
Okay.
That's half of that.
Okay.
And this equals 180, so 180 minus 70 is 110.
Oh, okay. You're doing USB. Okay. Okay. At first I thought you were doing the triangle.
No.
The triangle sum. But you ended up doing 180 degrees.
Yeah, because a line
minus.
Yeah.
Okay. I like how you did that different. I wasn't expecting that. I'm sorry. That's why I'm thinking. I wasn't expecting that one. Okay, good. Good. Okay, we're going to go on with RVU really quickly. RVU. This one, RVU, here. That's kind of like the example we just did and the very last activity we did. Margaret, go for it.
You do 140 degrees
Okay.
minus 30 degrees, and you get 110, so you divide that in half, you get 55
Good.
degrees.
140 minus 30 gives you 110. Divided in half, 55 degrees. Okay, that's the last theorem we just went over. How about USV? Let's point that one out. USV. Going here. I actually got a different way from one person that I just really wasn't expecting. I had one way in my mind, and somebody else gave me a whole different way to think about it. Michaela.
I used the triangle sum theorem,
Okay.
and we just did RVU, so I know that that is 55 degrees.
Okay, so she knows that this one is 55. Okay.
And since SUV, I
This
used
one?
the what's it called, the arc intercept theorem,
Right. Okay.
to find out that that was 15.
Inscribed angle to get this one 15
Yeah.
because it's half. Okay. So far we have 55 and 15.
And I added them together, and I got 70. So I did 180 minus 70, and got 110.
Okay. She did 180 minus 170, got 110 for this angle here. So she ended up with 110 for this by doing triangle sum. Okay. How about Leah? Tell me what you did because I was on a whole nother different. I was on this inscribed angle and getting the triangle sum theorem. It didn't even occur to me.
Angle RSU, we already figured out that equals 70.
Okay, we did this RSU, which was 70.
Because of the R equals 140. And then R line or segment RSV,
Okay.
that line, the angle of it equals 180.
Okay, it's a straight angle. Has to
Yeah.
be 180.
And so you do 180 minus 70 to get 110.
And she got 110.
That's the easy one.
That's an easy way. Well, it didn't even click in my head. I'm sure it didn't. I was surprised Leah got that. And last one, RWS. Real quick, don't go. RWS. How would you get that one? She says 95. You say 95.
Sum again.
You did triangle sum.
I did, you figure out what our UT equals 90, and you do 100 plus 90 divided by 2.
Good. Okay. Thank you, guys. Study, 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 study. Tomorrow.
Tomorrow?
Tomorrow. Final.